All right, I guess we'll get going. Thanks for coming, everybody. My name is Brett Murphy. I work for Enthought. I'm now the organizer of the New York Finance Python Users Group. Heather has switched it over to me, so I'll be taking over from Heather. Like I said, thanks for coming. Tonight we're going to be talking about, Kelsey Jordahl will be talking about QuantLib and PyQL. PyQL is a sort of new, nice Python with very Pythonic APIs interfacing to QuantLib. So Kelsey's going to go through how or what QuantLib offers and how to use PyQL with QuantLib to develop applications in Python with that. Now, we had originally, or Kelsey was originally planning to use his Mac over there to do some live demos, but the connector on the laptop seems to have busted. So we're resorting back to slides and some IPython notebooks. So you will get to see some Python, just not live with QuantLib. So sorry about that, but we'll still have plenty of material to go through. So, Kelsey.
Okay, thanks, Brett. And my name is Kelsey Jordahl. I work with Enthought. I'm based here in New York. My background with Enthought has mostly been working with financial clients on various projects. So the particular thing I'm going to talk about tonight, I want to move around, but the microphone's here. The thing that I'm going to talk about tonight is PyQL, which is a set of wrappers for the QuantLib library. How many people here have used QuantLib? A few. Okay. So I'll give a little bit of background about what QuantLib is, and then talk specifically about the Python wrappers here. So QuantLib is an open source quantitative finance library that's written in C++, and you can download from the QuantLib site bindings to other languages, including Java and C# and Python. So there exist already some Python bindings. So I'll show you the difference between the Python bindings for PyQL and the ones that come with QuantLib, and why you might want to use these instead of the default ones. So QuantLib provides tools for financial instruments, things like yield curves and pricing engines, and you can have very specific implementations of them. It has a nice simulation framework. I'll show you a brief example of that a bit later, going through the Python API. And it also has really nice date and time management. So I know some people use QuantLib just for the calendar management that it can do. So if nothing else, that's nice. If you're interested in QuantLib itself, here's a link to the QuantLib website and a really nice, useful documentation about it. Let me open these up in separate windows here. This is the main QuantLib website where you can download the software itself. All right. So there's the latest zip version, and I'll show you where the bindings are. It's opening up. The other languages part, I think, is in, yeah, there we go, in the other languages folder. So if you download this QuantLib swig zip or tar file, then you can download the Python bindings. Okay, and then this other link, this is implementing QuantLib. This is the blog by Luigi Bellabio, who's one of the core developers on QuantLib. And this blog is also becoming an open source book. So really nice reference part for these things these are the existing chapters as of right now. So 7 chapters and a couple appendices. Whoop. There we go. And these are all PDF versions. This is just the code conventions, but some really nice background on the library itself and implementations, all on the C++ side. Right. So this is the core QuantLib stuff. Right. So if you're interested in that, that's the sort of canonical reference now. That's the best place to look these things up. Okay. There. Now let's talk a little bit about the Python bindings for this. So why would we be interested in having a different set of Python wrappers for QuantLib than the ones that already come with it? Because the wrappers there are pretty powerful. They wrap most of the API, but there's some things that you can get if you do it a little bit differently. One nice thing to have, if you're used to working in Python, you're used to built-in documentation, doc strings for every function and class that you use, and you can introspect that interactively. That's really nice. You can have a proper namespace on the standard QuantLib wrappers. Everything's in a big flat namespace at the top. You can have things under currencies and different instruments and things like that. To separate those a bit, you can have an interface that's more Pythonic, a nicer interface to use, and I'll show you some examples of that, why it is nicer to use than the other one. And it integrates better into the Python ecosystem with things like NumPy. If you're going to switch back and forth between doing something in QuantLib and do your own calculations with a NumPy array or something like that, that's a lot easier. And we'll also have easier access to some of the parts of the library that aren't exposed by the Swig wrappers. And if you're going to write wrappers to expose new parts of it, you'd prefer to do it with this tool than with the Swig wrappers, and I'll show you a little bit of a short example of how you do a simple class. Okay, so what does PyQL use to do these bindings? The tool is Cython. So how many people have used Cython? How many people know what Cython is? Okay. So Cython actually does a lot of different things. It's almost hard to get your head around because people use it for many different things. One very common use for it is just as a static compiler for Python code, where you can declare static types and speed up your code by a factor of tens to hundreds if you're doing numerical computations. So it's really useful for that kind of thing. This application is somewhat related, but mostly orthogonal to that, or complementary to that, I'd say. That is, you can use Cython to wrap APIs from C and C++ packages in Python and expose them to the Python side any way you want. And I'll show a quick example of that. So there's some C++ code that was written to support the library as well. And then these bindings work on QuantLib versions 1.1 or later. So I have it all working on my other laptop on QuantLib 1.3, which is the current download version. And that works fine. All right, so the code. This is an open source tool, as QuantLib is. So you can download and compile QuantLib yourself, and you can download these Python bindings and build them. The main dependencies, other than QuantLib itself, are Cython, maybe a few other things, but it should be fairly straightforward if you've been compiling other things. And this is all up on GitHub. Let's click that. Right, yeah, there's the actual code. Also, the examples I'll be showing here are in the examples directory. So these notebooks are, I'll show a few of these static versions of them in a little bit later on. Oops, I just closed my window, didn't I? Sorry. Go ahead.
Lose the presentation.
Yeah, lost the presentation. Do you know how to get back to that?
Yeah.
Like recently closed tabs or something?
The presentation.
Oh, you could just click it again, that's fine. There we go. Yep. All right, thanks. All right, this is it again.
Windows now.
Yeah. Okay, there we go. All right, so to some actual code. This is a very simple C++ class. This is from QuantLib itself. This is the simple quote class that just has a few methods on it. So it has a value method, is valid, and set value, just to set that value key. Okay, so what does it look like to build a wrapper for that? There are some headers that I'm not talking about as well, but this is the Python code that exposes that same class into Python. So this will be compiled to a Python class, which will be exposed as a Python class when you import the library. And this wraps the same methods as were in the simple quote in C++. Right? Now, if you look into it, the core here is there's a smart pointer that's just referring to that C++ object. And then we have, for the value property, we have a get and set that's going to use the value method and the set value method. Right? Simple enough. One other nice thing is there's a double underscore str, right, which is the string representation of the object. So that means there's going to be a nice output of the object if you say print your simple quote object, it's going to give you some result. Yeah, so unfortunately I don't have a live version of PyQL on this machine because we couldn't get my laptop hooked up, but let me sort of fake it here. If we had the right version, what it would look like, what the difference between the APIs for the simple quote object, if you did it from QuantLib, you would say, okay, from QuantLib, import simple quote, right? And maybe you want to call it something. We'll say this is swig simple quote. Okay. Unfortunately, this isn't actually going to work, but let's pretend this will work, right? So if you had done that, then you could say, sorry? Yeah. Yeah. It's still not going to work, but it doesn't work for the different reason. Okay, there we go. Now we at least get an import error. So we've gotten the appropriate exception. But in any case, we don't have it built on this machine, so it's not going to import. But then once we have a swig simple quote, we would say, I want to create an object that is an instance of that swig simple quote, right? And I could give it a default value, say it's 50, like that. It doesn't have it, of course. I could fake it, but I won't take the time to do that right now. And then now if I wanted to query that object, how would you do that? This is the swig wrapper, so you would do it exactly as it is in the C API, the C++ API. And this would look like, so I want to query the value on that object. It would be spot.value, parentheses, right? So that's a method call on that object. That would return the value. That should print out 50. It won't. This is not a very satisfying demo, I know, but it's what we have. If anybody's really interested in seeing some of these things, I can do it on my laptop for individuals afterwards. But all right, so that's how you get the value. Now, how do you set the value? You do spot dot set value like this. Sorry, that's typo 2. Right. So if I wanted to set that value to 75, I would do that. So that's actually using the set method. Okay, so that's a bit awkward in Python, right? You might be used to doing that in C++, but if you're used to programming in Python, you don't really want to handle different methods for setting and getting values and things like that. It's like that's not what Python's about. Doing that in the swig wrapper, if we, that would be from QuantLib .quotes import simple quote. Okay, so then the object has the class itself has the same name, right? So you do the same import. This isn't going to work either. But now, say I make this spot object to be this PyQL simple quote. Now this is in the Python binding, and I define it the same way. Now, to query the value on that object, it would be just spot.value. And that would, as a property, I don't have to call it as a method, okay? So that's nice. You don't have to do the parentheses, maybe not a big deal. But you can also assign into it. It's a property with getters and sitters built in. So you can assign directly into that property. If I just want to assign the new value to that attribute, all I do is a straight assignment like that. There's no separate setter method. Right? That's standard Python properties, but we can expose all of the internal QuantLib objects like that. If it's something that should be a property in Python, we can make it a property in Python, and it's much easier to work with, especially interactively, if you're going to do things like this. Another really nice thing is if you say print spot, this instance of your simple quote object, what it would do is print, it's a simple quote object and the value is this, right? So it would be a nice human readable version of it that's always there for you. If you do that for the instance of the swig wrapper one, you'll get some cryptic thing about this is a swig wrapped object at this memory location, and you might see that it's a simple quote, but you won't actually see the value that's inside it. And it's not really meant for you to read. It's meant to be something that you can look for in a stack trace or something like that, right? So the human readable strings are nice as well, as are the built-in documentation. So you've got doc strings built in. So if I were to say simple quote question mark at a live IPython prompt, you would get the documentation for that particular class, or for a method on it or something like that. So that kind of thing is really nice. Okay, so all right, so that's the wrapper code. Let me just show one other example of the difference, and this is already printed out here in the APIs between the swig wrapper and the PyQL wrapper. So this is defining a Black-Scholes-Merton process with some parameters, and using that particular pricing engine and getting the net present value on that option. Okay, so to set it up like this, these are all directly QuantLib objects. The PyQL code isn't that different. They all have the same names. They basically take the same arguments. But there's some boilerplate that you don't have to do. See, particularly there's one layer of handles on quotes and yield term structures and so on that you have to wrap things in to call them in the Swig wrapper. And the Python wrapper lets you do that directly, so that saves you a step. And then you'll also see that the names for the methods are more Pythonic. They're not just a straight C++ names. All right, so set pricing engine, that's the convention for a method as opposed to a class name in Python would be lowercase words separated by underscores, right? So that's just the common convention, and PyQL tries to follow those conventions. And then you see that net present value, instead of being this method call on NPV, is actually a net present value property, and that's a computed property for you that it'll retrieve anytime you ask for it. Okay, so now I'll show a few examples of IPython notebooks that actually run through some examples of using the PyQL bindings to do a few things. So I was going to do all these live, but we've got static versions of these notebooks up, so that this should all work. All of these examples are up on the GitHub site, right? So you'll be able to look at these as well. Okay, so there are a few linked notebooks here that are going to do a number of steps. So let me go through these, fairly briskly. But the first notebook, this is called USD Deposit Swap. Actually, here's another question: how many people have used the IPython notebook before? Is everybody familiar with this? About half. So those of you who aren't familiar with the IPython notebook, this is an interactive environment where you can type live Python code and execute a cell and have static text blocks that are formatted and get graphic output and so on. So it's a really nice interactive way to see your work and to save it and possibly present it to other people. This is actually another view on an IPython notebook. This isn't a live notebook that I can type in, but this is from the NB Viewer website. Let me not click something wrong here. This is pointing at an actual IPython notebook file and just giving us a visualization of it. Right? So this actually came in rather handy when I didn't have my notebook to do this directly. We're just looking at static views on these same notebooks. And so once you have these publicly, you can send this Python view to anyone, and they can look at your notebooks. Right? So it's a nice way to share code. Okay, so anyway, this first notebook, what it does, it goes and loads some data on U.S. interest rates in, let's see, yeah, so swaps and LIBOR from the U.S. Treasury site. All right, so it loads those and it plots the yield curve for those things that it downloaded. And then it saves it in a file that the next notebook can use. So this doesn't actually use QuantLib yet. It does use pandas as the data structure to save things as an intermediate thing, and all these notebooks are going to be loading things in pandas objects and interacting with QuantLib with the pandas data. Okay, so this file, let me get this. Now you get to see how you use the notebook viewer as well. All right, so I'm going to copy this location. This is the raw IPython notebook file. So if I go to the NB viewer site, you can paste in a public URL for any object. And there. Yeah, okay, there we go. So this is the option quotes notebook. So it just rendered that notebook for me. There's one more step where you actually download option prices. Let's see. That actually doesn't use QuantLib either, but if you're actually going to run these, you have to do these in the right order. It's the SPX options notebook. So if you were going to run this, the SPX options actually downloads options data for the SP 500 options for a certain time range from the Chicago Board of Trade website and saves that in a pandas file. And then that's the input. The input from the USD LIBOR and from the SPX options notebooks become the input to the option quotes one. There we go. Okay. So then this notebook actually uses QuantLib. So now, given these historic options prices, this goes through a series of calculations where it calculates the implied risk-free rate and dividend yield for that time, the volatility. So it's calculating the at-the-money volatility and then the Black-Scholes implied bid and ask volatility given the bid and ask options prices. Okay, so here, these are this is the background equations that we're solving. I should note these notebooks were made by someone at the University of Paris, Patrick Haynaf, who also has a related book on doing this in R. So if you're interested in R too, these same things are done in that. This is his translation of his stuff to Python, and specifically to using the PyQL wrappers for QuantLib. Okay? So I should also say I'm not a quant. I've worked with financial instruments like this, but I don't spend a lot of time looking at the equation side of this, so some of you may know this better than I do. But what does this actually look like when it's doing the calculations? So here, there's really one big function that's calculating all of these different things, and those are, so doing some work in pandas, but here is the black formula implied standard deviation, so getting the implied volatility of that instrument, right, with all those parameters. Right, and then we're setting results into pandas data frames. Oops. Look here. Here we go. And then it's going to save all this result into another pandas file that we can use for the next notebook. Let's see if I have that one. So the instant process simulation. There we go. And then this is the calibration of a model on those implied volatilities from the previous output. So calibrating a Heston model, which is a stochastic model where both the price and the volatility are stochastic variables, right? And to calculate the parameters for a Heston simulation model. Okay. So walks through all of that and returns the results as a data frame. Right. And then there we go. And then finally we'll plot the results for the implied volatility for the bid, ask, and the at the money curves there. Okay, so the simulation processes, that's one example of a thing that is actually better exposed. It's there in QuantLib, but it's better exposed in the PyQL wrappers than in the SWIG wrappers. You actually don't have access to these simulation objects in the SWIG Python wrappers. So this is a simple Heston process simulation. So this is the Heston model where you've got an asset price that's governed by a process, and the variance is also a stochastic process. All right, and now this is a pretty simple example of setting up a model with some parameters. Right, and here's your Heston process object, and now you can basically do a Monte Carlo simulation of it to say, okay, we want to do 200 paths on this model with these parameters. So 100 forward steps in each path, and set a random number seed so we always get the same results. And here we just plot out our paths directly. All right, so these kind of simulations are really easy to do in PyQL, and you can set these up and do them in different ways. Okay. All right. So I think that's as long as I'll spend on the IPython notebooks, but I'll make sure that they're all up to date on the GitHub site, and you'll be able to look at that. Okay. So let me just mention a few things that PyQL still needs work on. One, not everything is exposed in PyQL yet. There are still things that haven't been wrapped, and those still need to be done. And more work can still be done to make the wrapper even more Pythonic. So that's the goal, and we can show some examples where we've done that. But we'd certainly like to go farther and make it easier to use in Python, reduce the boilerplate a bit more, and make it easy to use interactively. Better integration for large data sets, just to handle data models for big objects. That we can do NumPy arrays now, and we could probably have better handling for that. For processing in parallel, OpenMP support would be really nice. Python actually has good support for that, so that's certainly possible, and could do things more efficiently. And then one very glaring problem with it right now is that it hasn't successfully built on Windows. We need to do that. That's just a matter of time and working with the Windows environment. We have been running this on Macs. For the most part, it works fine on Linux as well, but we haven't spent the time to get it built on Windows. There's no reason in principle it shouldn't. It's just someone needs to spend the time to do it. It's open source, so if anyone's interested in chipping in on that, that would certainly be helpful. And then the primary credit for the PyQL wrappers and for these examples are from Diederik Pinte, who's a developer of ours at Enthought, based in Europe, and Patrick Enaf, who's at the University of Paris. Okay, and at that, I think I will stop and see if we have any questions. Thanks. Yeah.
You mentioned that PyQL is open source.
Yes.
I was wondering if QuantLib itself is open source.
Yes. Yes. Absolutely. Oh, yes. Sorry. The question was whether QuantLib itself is open source, and yes, it is. So that's one of the really interesting things about this, about QuantLib. So if you work in a financial institution, you know that you've probably implemented these things internally and no one ever sees them, right? So this is one of the few places where all of this has been written and exposed, and you can go use these. So one of the common questions about QuantLib is, who's using it in production? I think that's it's a good question, and I don't really know the answer. I know there are some. There is a company that supports it. The name escapes me right now, but if you look at the QuantLib website, is it? Where is he? So Luigi Bellabio actually works for the company that supports it. Where are they? StatPro. There we go. So StatPro is the company that primarily supports it. And you can get commercial support from them, but the library itself is open source. I believe they actually have a QuantLib 2.0 commercial version as well. So there might be some portion of it that's not open source, but there's the one I've talked about is all open source. Yeah. Yes.
I mean, Swig has one advantage. Actually understands C++ headers, right? So keeping up to date with the QuantLib, in sync with the QuantLib is relatively easy for these guys. In your PyQL wrappers, I mean, it seems to me that there's a lot of really manual work to get this up to speed.
Yeah, that's right. The question was, Swig can automate a lot of the wrapping of headers, generating headers and so on, where PyQL looks like using the Python is more manual work. And yes, I think that's true in general. Python does have helpers. You can define templates and do some things automatically. But if you're really going to do it well and carefully expose these things in a nice way, it does take work. That's for sure. And then if the API is changing frequently, that can be a problem, right? As long as the API is stable, you're probably not a big problem. But yeah, that's true.
Any kind of tool to sort of build this thing automatically, or is there any plans to do that?
Certainly, the more automatic, the better. And it's a matter of how much effort goes into this development specifically. But I would say there are certainly other Python wrappers that do put a lot of effort into that and making it more automatic and defining templates so that you can do more automatic following of the API. So there is work on the Python side on that to make it easier to more automatic like that. You're right. That's one of the advantages of Swig, that you can blanket the whole API and just regenerate it. It takes a long time, but once you do it, it's there. And there's some truth to that. Yeah. Other questions? Yeah. Yeah. Okay.
How much of QuantLib would you say is already implemented in PyQL?
Oh, I don't know the percentage. Somewhere over half, but under 90%, something like that. I don't know exactly. You'd have to look at it. Yeah.
Have you had any feedback from the core QuantLib team on that, or perhaps try to make some inroads to maybe making PyQL part of it, or?
Yeah, I don't know about that specifically. It's actually listed. Yeah, so there certainly has been communication, and it's listed if you. I don't remember where it is, but other languages platforms. So if you look at the official QuantLib page, PyQL is listed as an alternative. Here we go. Yeah. An alternative set of wrappers provided. So, so they're certainly aware of it. Yeah. Yeah.
You mentioned the data and time classes earlier. Can you talk a little bit about what you've done there, and have you done anything with NumPy integration?
Yes. So the date and time classes use NumPy objects underneath them in the PyQL wrappers, right? So and going back and forth between Pandas objects, because it also uses NumPy datetime objects. Going back and forth between the Pandas datetime handling and the QuantLib datetime handling is, or PyQL datetime handling is nice. So that is pretty well integrated, right? And both, I would say both QuantLib and Pandas are known for their date and time handling, and yeah, they seem to be pretty compatible. Yeah.
Has there been any performance analysis for large data sets?
There have been a few benchmarks, and the PyQL is a bit faster, but for really significant computations, it's going to be dominated on the C++ side, and they're not very different, right? So there's a lower overhead with the PyQL than with the Swig wrapper, but where that would come into effect is if you had many objects and you're implementing many things. If you're doing a large computational intensive thing, then the overhead difference isn't going to be huge.
So how do you leverage the C++ code in NumPy for calculations, given that QuantLib is probably doing calculations? What advantage do you have going into NumPy arrays? Is it just as a holder for the results, or is it actually for calculations as well?
Yeah, I mean it's for a holder for results, right? So you get the. So can they share arrays? You can certainly put the output directly into a NumPy array, but it's. Yeah.
Is it shuffling data around?
That's what I'm thinking about right now. So sometimes it is, and sometimes it isn't. So certainly watching where that happens is an important thing, right? So I think there are places where that data shuffling could be reduced. Yeah.
On that question, did you down compile your Python code close to C like LLVM compiler so that you can increase your speed?
Oh yeah. So that's what Python does. So it doesn't go to LLVM necessarily. It goes to machine binary. But yes. Sorry. Oh, sorry. The question was, have we done anything to compile the Python down, or the PyQL down to LLVM? And I said not specifically LLVM, but the Python is already compiling down to native machine code. So yes, so we're getting, you should get tens to hundreds of times speed up from that. So that's what Python's doing.
Are there any bindings going sort of the other way so that the QuantLib can call products or models written in Python?
Okay. The question is, are there any bindings the other way so that QuantLib can call things in Python functions? And I'm not aware of any. These bindings are all the same direction. You could certainly use the output from Python objects, in your own script. You could write your own script where you do something, have the output from whatever it is, pass that into QuantLib. But if QuantLib directly calling out, I'm not aware of that. Any other questions? Okay, if there aren't any other questions, we'll end here, and I'm available for further individual questions afterwards. So, thank you.